Okay, great, thanks. Yeah, this is part 3 of our electric circuit question. So we are going to look now at this question. It's an exam question. It's a combination of the parallel resistors and the series resistor. So let's read the question. It says, in the circuit diagram below, the reading on the voltmeter V1 is 12 volts and the reading on ammeter A1 is 2 amps. So this means that this battery has a voltmeter, and this voltmeter is reading the voltage of 12 volts. So the battery is producing 12 volts. So we know that this side is a positive side of a battery. This side is a negative side of a battery. So electricity will come from the positive side of the battery. This is how current will come. We call it I total. So that electricity, when it's passing A1, this is the ammeter. The function of the ammeter is to measure current. So here is the current that the ammeter measured is 2 amps. So that means that I total from the battery, that current that came from the battery going down is 2 amps. We already know the total current is 2 amps. And then that current goes down, and then when it comes at this point at the junction, what happened? It split. Part of that current goes to the 6 ohm, another part of the current will go to the 3 ohm. So I'm going to call the current that goes to the 6 ohm, I'm going to call it I6. So that's I6. Then the current that goes to the 3 ohm, I'm going to call it I3. So we don't know how much current goes to the 6 ohm and how much goes to the 3 ohm. But at this point, that current meets again, and then it comes out as 2 amps again. And then it goes to the 4 ohm. I'm going to call that current I4. So that's what we know about the current. This V2 will measure the voltage of the 4 ohm. So now let's go to the question and check what they want us to calculate. So question number 11.1. Calculate the total resistance of the circuit. So we know what they want here. They want R total. So let's calculate the total resistance. So before we calculate the total resistance, we first calculate the parallel resistors. So the parallel resistance from the parallel resistors is 1 over R parallel is equals to 1 over 6 plus 1 over 3. 1 over 6 plus 1 over 3. There are 2 resistors in parallel. So take your calculator and check. 1 over 6 plus 1 over 3. That is 1 over 2. So we have 1 over 2. Remember, on the left you have 1 over R parallel. So you have to flip this over to be R parallel. Now let's say right, it was 1 over 2. You flip it over, 2 ohms. So R parallel is 2 ohms. These 2 resistors, they make 2 ohms. Now, in order for you to get now R total, the last step now to get R total, let me show you a simplified diagram. This is a simplified diagram. This is R parallel. And we got R parallel to be 2 ohms. This is that 4 ohm. So I have made the parallel resistors a single resistor of 2 ohms and this one is still 4 ohms. My battery is still 12 volts. So to get R total now, that means we have to take the 2 ohm, add it to the 4 ohm because they are in series. Then I can easily see that my total resistance is 6 ohm. So that's what you do here. R total is that 2 ohm from the R parallel plus 4, which is from this resistor. Then it gives us 6 ohms. That is R total. So we're done with that one. Now let's go to number 2, 11.1.2. Calculate the reading on V2. We want now this reading, this voltage. V2 is the measure of voltage. They call it a voltmeter. It measures voltage. So we want the voltage of 4 ohm resistor. We want this voltage now. We know this current that is going to the 4 ohm is 2 amps. It is the 2 amps that is coming up through the 4 ohm. So let's find the voltage. The formula for the voltage we know is 11.1.2. The voltage of the 4 ohm is equals to I of the 4 ohm multiplied by R of the 4 ohm. Its V is equals to I times R. Go back to your rectangle. V is equals to I times R. So what is the current of the 4 ohm? It is 2 amps. Multiply. What is the resistance? It is 4. So 2 times 4, that's 8 volts. So we get the voltage of V2, the voltage across 4 ohm to be 8 volts. So that tells you, if you go to your simplified diagram, if this resistor now, which is 4 ohm, is taking the voltage of 8. Imagine this one is taking the voltage of 8 volts. So if you take 8 from 12, how much is left? If you take 8 from 12, how much is left? You're left with 4. So that means now the amount of voltage that is remaining here is 4 volts. Where is that 4 volts going to? It's going to go straight now and be taken by this resistor. So that resistor is going to get the 4 volts. This one took 8, this one took 4. So we know the parallel resistor took 4 volts. So let's go and apply that in our diagram. So we know this one is going to be 4 volts. We know this one is going to be 4 volts because we saw it from the simplified diagram. And we know this one took how much? 8 volts. So I want you to remember that this one is 4 volts. This one is also 4 volts. The other one is taking 8 volts. 8 plus 4 is 12. So let's check the following question now. So that information will help us to get the following question. Calculate the reading on A2. Now A2 is the ammeter. They want now the current now. They want this current, the I6. The current passing through the 6 ohm through the A2. A2 is the ammeter, it measures current. So we want this current now. Can we find the current of I6? Yes, we can, because we do have the voltage, we do have the resistance. So let's find that current I6. So we say now 11.1.3. The current of I6 is equals to V6 over R6. Check the triangle. I is equals to V over R. V over R. So that's the formula for the current. So what is the voltage? We said the voltage is 4. What's the resistance? It is 6. So for this current, the voltage is 4, the resistance is 6. So let's calculate now. What is that? 4 divided by 6. 4 divided by 6. 0.67. 0.67. So we take two decimals, 0.67 amps. So this is that A2, which is that I6. So it reads 0.67. So that is the reading of the ammeter A2. Now for interest's sake, let's also get the reading of I3. Let's check what is the amount of I3. I3 is a 3 ohm resistor. So let's find that current. I3 is equal to V3 over R3. The voltage is 4, the resistance is 3. So what is 4 divided by 3? It's 1.33. 1.33 amps. So we know that when we add these two, they must give us 2 ohms. They must give us 2 ohms. Okay, I don't know what is happening here. Okay, yeah. So yeah, when we add these two, they must give us 2 amps. Let's check. If we add this one, if you add this one, 0.67 and 1.33. 0.67 plus 1.33 is giving us 2. So when you add these two, still giving us 2 amps, because it means that the current was 2 before it was splitted. And lastly, if you check now, this resistor, which is 6 ohm, is getting 0.67 amps, but this one is getting 1.33 amps. The small resistor gets large current. The big resistor gets small current. So I'll continue now in the next video.